So today I'll talk about a paper that has been recently published in JAMIA, and this paper focuses on phenotype evaluation. And now, phenotype development and evaluation are oftentimes the most time-consuming parts in clinical studies, and that's because it usually takes a lot of time. Yet, we want to make sure that we capture the patients accurately because we want to make sure that we study the patients we want and we minimize measurement error. And the common approaches, the gold standard is manual chart review, where somebody has to go through the whole patient record and label them as cases or controls. It is considered to be gold standard, but it is resource and time consuming. So what a lot of people do is they borrow the phenotypes from the literature, do not evaluate them, and rely on the previous performance shown in the literature. That doesn't work well. The community has been working on the tools that help with this process, like cohort diagnostics or phi-evaluator, but yet we don't feel that we are done solving this problem. And because the gold standard chart review is so time consuming, and because somebody has to go through all of this data to figure out which pieces are relevant, we decided to try to solve this problem and come up with the tool that we called Keeper, a pro-action tool that mimics chart review on structured data like ECHARs or claims. So even if you don't have the access to charts, you can use this tool to do phenotype evaluation. And this QR code will lead you to the paper itself, but also it's published in JAMIA. And we followed a couple of principles when designing the approach and building the tool. And the first principle was we wanted to make this tool and approach interpretable. So we followed the clinical reasoning steps that clinician takes in order to diagnose a patient in real clinical practice. And what it translates into on the tool level is that we want to extract these common clinical buckets of information for each patient. Think presentation, think prior history of disease, differential diagnosis, diagnostic procedures, labs, treatment, complications, all of the buckets of information that make perfect sense to clinicians. Also, because we said that we have a lot of information in the charts or in the structured data, we want to reduce the amount of information we show to only relevant information. So we want to limit it to the phenotype of interest and not the whole volume of the data. And finally, this approach should be applicable to a broad range of data sources and conditions. So we need to both standardize the input or AMAP common data model, and also standardize the output so that everybody sees the same output for whatever condition you choose to study. And based on those principles, we built a package, an Odyssey package. And what it does, it takes a cohort of patients identified by a given phenotype. It also takes the list of the concept IDs that the user supplies to the tool. And this set of concept IDs is one of the crucial parts of Keeper because you essentially list out the IDs of the concepts that you want to see that are relevant to a given condition. Keeper takes these two inputs and extracts all of the information within certain timeframes. And then it outputs a table which can be saved as a CSV table that has a record per patient or row per patient, while columns correspond to the clinical buckets that we saw before. And of course, we also wanted to do some sort of evaluation of this tool. So we ran an experiment on Columbia electronic health records. And the first step of the experiment was to create the gold standard and the Keeper profiles. We selected 4 conditions: type 1 diabetes, acute appendicitis, chronic obstructive pulmonary disease, and end-stage renal disease, which represent a broad spectrum of different conditions. For each condition, we executed an eMERGE phenotype, and we randomly sampled 20 patients per condition, And we then created the gold standard by having 2 clinicians iteratively review the full chart and all the structured data until all disagreements were resolved. And those 80 patients with their labels was the gold standard. We then independently created keeper profiles for the same 80 patients. And when we ran the experiment, we had yet again 4 independent clinicians reviewing keeper profiles for these patients and independently reviewing charts for the same patients. And we followed 2-sequence, 2-round design with different permutations of the methods to make sure that we minimize bias and crossover effect. And as a result of this experiment, we had this data set of 160 patients classified or adjudicated with keeper, and also 160 patients classified using chart review. So now with 2 data sets, we can compute all sorts of different metrics. And we focused on 2 buckets of the metrics. First, we wanted to look at how long it takes to review patients and classify them. And second, we wanted to look at the agreement of the methods with the gold standard, or how accurate those methods are. We also wanted to look at whether manual chart review agrees with keeper results. And we also wanted to look at how consistent the review is, or the agreement between different clinicians. And what we saw is that, well, first of all, there was a statistically significant difference in time needed to review patient profiles. We saw keeper consistently performing twice as fast comparing to chart review across all rounds of experiment and across all conditions. We also saw that keeper enables more consistent review. So 2 different clinicians can arrive at the same conclusions regarding the patients more often when using keeper compared to charts. And also, of course, we wanted to examine whether keeper is accurate. So when we compared chart review and keeper to the gold standard, we saw that keeper enabled as accurate patient classification compared to the gold standard as chart review. So these were really encouraging results that highlight the opportunities for us to use keeper to review more patients, to use it to perform phenotype evaluation for even small phenotypes that we all use in our clinical studies. And we yet again made this package available as the Odyssey package. And just to remind you, what it takes is the cohort that was identified by the phenotype, and it also takes the concept IDs for the clinical elements you want to see. And the second part is probably still quite some time consuming. So if you want to use this package, I would suggest you reaching out to me so that I can guide you on how to identify those elements or identify the concept IDs you want to see, but also we're working on making this process easier. On top of that, we are now trying to use this package, or I should say we are starting to use this package in a real clinical studies. So yet again, if you're interested, I would encourage you to check it out and also talk to me. And if you want to hear more, this work was presented in much more detail at the Odyssey Symposium Plenary. So I attached the link where you can see the slides and where you can see the video, and it really goes into more details on our methods, on our evaluation, and also our potential further steps on improving this work.